Hello and welcome back to Python Deep Learning for Beginners. We're beginning a new section today about using convolutional neural networks to solve increasingly complex tasks. In this section, we're going to take a look at three different topics. We first go into very deep CNNs, seeing how it would impact our performance. And then we talk about how we can make it better by going through the concepts of batch normalization and other fine-tuning techniques related to CNNs. Very deep CNNs. In this video, we're going to take a look at number 1, implementing a very deep CNN in Keras, and what kind of thing happens when you train the CNN. Let's go into our Jupyter Notebook and take a look. So I'm in my Jupyter Notebook and I have loaded up my Chapter 5 notebook using CNNs to solve increasingly complex tasks. So if we remember how we go from linear regression to a perceptron to a neural network to a deep neural network, one of the main hallmarks, indeed one of the main definitions of deep learning is we have a lot of layers in our neural network. So we have learned about this new magical way to think about image data or any data that is 2D and based on a grid using convoluted layers in Keras. And so one of the main temptations for us to do is to, much like how we would do it in a normal fully connected neural network, is to just add many layers of convolutional layers into our Keras model. So this is what we exactly have done here in the first part of our notebook, where what we have done is we created a sequential model in line 1 here in the first box. And in the second box, we simply created a bunch of convolutional 2D layers, starting with the one that has our inputs, and then adding randomly another 6 layers of convolutional layers, all 2D convolutional layers, with 32 filters each, and a kernel size of 3 times 3. At the end of these 7 layers, we added a flatten layer to flatten all of the outputs of the convolutional layer. And we added this to a dense layer, fully connected layer of 512 neurons with an activation with a rectified linear unit activation layer. And then we connected it to another layer, which has as many classes as we need for our classification purposes. And so what happens when we simply do this naively? So what happens is the complexity in the convolutional layer actually hinders the way we learn image data. And not only that, because there isn't a way for the neural network to learn sequentially higher and more high-level representations of the image, what happens is it gets stuck in local minima or local effects and fails to see literally the big picture. In practice, what you see as an expression of the neural network failing to learn from all parts and all different components and all levels of the hierarchy of this image, the effect that you will see practically is either your error rates do not converge, i.e. your error rates remain very high for a very long time and you don't really understand why, or you have this issue called a gradient collapse where all your gradients go to a particular value or 0 and the network just refuses to go anywhere or learn anything. And so the main reason here is because the convolutional layers usually need to be complemented by other layers such as batch normalization layers, rectified linear unit layers with other transfer functions, pooling layers, and dropout layers to make it learn effectively and also sequentially zoom out to the bigger picture as we have talked about earlier into this course. So this is what the problem is, right? So I encourage you to go home and try just stacking up convolutional 2D layers and see where you end up. Very likely that you're going to see that the neural network doesn't do anything. And so in the next video, when we go to the next video and I guess the bottom of this notebook, I'm going to show you what are the other layers you can mix into your CNN to make it learn effectively. And that's all there is to it. So this is a very simple theory exercise where we think, okay, if a deep learning network is about stacking up layers, can we simply stack up convolutional layers? And the answer is no, because there is not enough flexibility and expressiveness in your neural network for it to achieve anything material.